Morning. Today we are going to discuss about the lists. Okay. Before going to discuss about the lists, we have to we have to know the data types. Okay. We know that already we discussed about the some of the data types. Okay. We discussed already some of the data types. So already we worked on some of the data types. What are the data types? So just okay. So integer, okay, float, string, okay. On the that means on the data types only we worked. Okay, already I showed that. So some of the examples, report card. Okay, so in the report card, how the data will be arranged means it is a different. It is a collection of different data types. So report card is not built with only single data type. It is built with. It is framed with different data types. Okay, your name will be there, that is string. Your marks will be there, those are the numbers. Okay, your grade will be there, string, like that. So not only that one, now I want to introduce all the data types. Actually, I want to introduce all these things before. If I introduce means will maybe will be confused. Okay, if you know the proper understanding of the data types and all, then we'll go for remaining all other data types. Okay, we discussed already some of the data types and the numbers. See, broadly Python data types are numbers, sequence, sets, okay, none, mappings. These are all the four data types. Okay, among the four data types, okay, we'll discuss about the lists. Okay, before that, I'll give the brief introduction about all the things. Okay, whatever there here. First, numbers. We know that numbers means there are how many types of numbers are there? Integer is there, floating point, complex, and boolean. Okay, first go for the integer and float. Okay, example, see here, English 45 is there. So if we for suppose see integer, sorry, English equals to 45. So type, uh, if I type this command, okay, type of English, I will get the integer. So type command is nothing but it displays the value that is pertaining to which data type. Okay, so here 45, that is belongs to integer data type. For suppose total, otherwise average, I'm giving the average as 70.5. Okay, now if you type this command, okay, type this command, if you that means if you apply this type command on the average to know the data type, simply it gives the float. Okay, so next, if you know, for suppose str1 equals to some, okay, uh okay, some school, you can give any school. Okay, for suppose Shantiniketan. Okay, this is this is the name of the school. Okay, now if you want to know the this data type of str1, so it gives the string data type. Okay, so you know that numbers are the two data types are there, float is there and integer is there. Integer in the sense all the rounded values without decimals. Float means the numbers with decimals is called the float. Okay, and string means group of characters up to this part we know that. Okay, next, boolean data types means if you compare any two values, it gives the result. Okay, for suppose x equal to 70 and y equals to 100. If I give the condition x greater than x less than y, x less than y means is correct or not. 70 less than 100, correct means true will be generated. So this true is called boolean. Okay, or suppose x greater than y, what will be written here? False. So for conditions we are using true and false values. Okay, for we are using if condition, else condition, nah? So if condition, automatically you are writing if x less than y means system will check only the true value. If true means automatically the block will be getting executed. Okay, actually we are comparing 70 less than 100, but system compares the value, boolean value. If it is true, it allows to execute the next statement in the particular condition. Okay, so this is about the boolean. Next one, complex numbers are there. See here, complex numbers, we know that they are IJ format. It represents the complex numbers which consist of real and imaginary parts. Okay, so very simple. If you want to build any program other than the Python to add the two complex numbers, it's a very hard task, that is. Okay, so much code you have to write, but that can be achieved. Okay, very simple in Python. For suppose I'm giving in the X, I'm giving the one, okay, complex number 1 plus 2j. Okay, 1 plus 2j, and second Y, one more complex number 3 plus 3j. Okay, so complex number a real and imaginary. So these two and all imaginary parts, and this 1 and 3 called real parts. Now we can easily directly you can you can add it and you will get the result. See, 4 1 plus 3 real part will be added, 4 2 plus 3 is added, and 5 is, so this much simple. So addition of complex numbers is very simple. Why? Because direct data structures are there. Complex number itself a data type. Okay, but it is not possible in Java and Java and C and C++. This type of complex numbers data types are not there directly. Okay, for that you have to write the programming. Okay, so this is one of the nice advantages of the Python. And you know that this is called dynamic typing. Why dynamic typing means we no need to declare any variable automatically at the time of for suppose we gave the x equal to 70. If you give the type, automatically system understands this is the integer, this is the number. Type 70 means this is the number, type x. Okay, not 70, because 70 is stored in the x. Now see, it's an integer. Or suppose in the same x, I'm storing 90.45. Okay, now apply this command, type of x. Now this is what? Float. So now again x equal to, I'm typing some name. Okay, Harish, for suppose. Okay, Harish. Now double quotes. Okay. Now type is the command, we know that, to know the data type. So automatically system itself, it is recognizing this. That means first time I gave the 70, it is an integer. Second time the x value is changed, but it will be again updated, and now this is float, now it is string. That's why this is called dynamic typing, and no need to declare any variables before using. Okay, so but in C, C++, Java, you should declare the variables. Okay, if you want to use x equal to 70, if you give in the Java or the C, C++, it gives the error. Why? Because before you have to tell to the system what value is going to be stored for Java, C, C++. But here that is no need. That's why this is called dynamic typing, otherwise weak typing. Weak typing also. Okay, that means no, it won't bother about the data types and all. Automatically it recognizes while the value is stored in the variable. Okay, hope you understood. Okay, now this part I completed, numbers. Now go for the sequences. We know that a sequence is nothing but group of items. Okay, those are indexed 0 1 2 3 like that. So already example means, see here, yes, in this sequence, there are three types are there: strings, lists, and tuples. Okay, that means first of all, what is a sequence? Collection of ordered items which are indexed. That is called sequence. It's very important. Now see here, example, say there is a name Shantiniketan. Okay, this is called string. Why? Because group of characters, but both are enclosed or both are indexed. All the, sorry, not both, all the group, the characters which are in the name, those are indexed. Okay, so those are ordered. So I can obtain all the numbers, all the items from all the characters from the name. Example, see, here I'm giving name equals to, for suppose, Gopal. Okay, so this is a string, we know that. Now I can obtain G by writing like this name. Okay, name is the variable name. So name of 0, if you type means G is, so G is printed. So all are indexed. G, the value of the index of G is 0. For example, if you want to access O, name of, okay, 0. Sorry, name of 1. Name of 1 means what is that? So that is in the index 1, 0, O is stored here. Okay. For example, if you want P, so how can you represent? Name of 2. In the name, the second letter, that means second means third here. Why? Because index starts from 0. That means here third. The third letter is P. Okay. If you want to go for fourth letter, name of, don't give the fourth because index starts from 0. That's why you can give the 3. So that's why this is called indexed. Okay, you understood. Like that, lists also same. Okay, lists also group of items. See, L1 equals to, so list is, okay, this is also group of items. We will see the list. See, a list is sequence of items separated by comma and it's are enclosed in the square brackets. Lists are enclosed in square brackets. Strings are enclosed in double quotes. Now see, 10, 20, for suppose Gopal. Okay, the Gopal has the marks like this: 15 English, 16 math, 17 science, 19 social, 100 in computer science, per suppose. Okay, so this is collection of items, any item, maybe no need of only the integers, no need of only the strings, it's a mixed type. Okay, a list is a collection of different data types. Okay, and those are also indexed. So I want the Gopal means very simple, L1 of, so L1 of 0, L1 of 0 means it gives the Gopal now. Why? Because the index starts from 0, the first item is Gopal. If we want L1 of 50, what you want to give? L1 of 50 means this is the 0, 1. The index is 1. So L1 of 1 is nothing but 50. Sorry, L1 of 1. L1 of 1 means uh, uh, this is, I used the small L1. This L1 is different. Okay, L1 of 1, L1 of 150. If you want 90 means what is the index of 90? 0, 1, 2, 3, 4. So L1 of 4, it gives 90. Okay, so all the sequences are indexed and ordered. Okay, and next tuple. So tuples are nothing but, see, tuples are sequence of items separated by commas and items are enclosed in parentheses. Okay, same. So we will see later elaborately about the tuples and all. Just we know that what is the tuple. T1 equals to, this is enclosed with parentheses. Okay, 10, 20, 30, 40. Okay, 50, like this. Okay, so this T1, T1 equal to 10, 20, 30, 40. But same, whatever the else, whatever the list stores, the way the items in which the L1 is stored, the same as in T1. But small difference is there. Lists are immutable. Sorry, lists are mutable. What is the mutable means? List supports item assignment. For suppose, and the L1 of, now I want to print the L1. So in L1, for suppose I want to change the value. I don't want the Gopal here. Okay, for that they will accept for change and all. For suppose here also I'm storing some value that is 85. Sorry, L1 of L1 of 0. I want to I want to change the first item, that is the index 0. So L1 of 0, I'm giving now 90. 90 is there already, 90 family. So if I print L1, okay, it accepts the item assignment. That's why this is called, okay, mutability. But the strings and tuples, they won't accept this type of item assignment. That's why they are immutable. So for suppose here the name, what is that? Gopal is there. So you know that, if you want to print the first item, L1 of 0 means what will be printed? G will be printed. Okay. Okay. But in the Z, for suppose I want to assign some other value other than the G. For suppose I want to give one more value. For suppose K, I want to keep it K here. Okay. So here, if you click here, str object does not support item assignment because this is immutable. Okay, strings are immutable. You have to understand that strings are immutable. What does it mean? Immutable means we can't assign any value once they are already stored. Once the item is stored, okay, in the strings or tuples, we can't again reinitialize any item. Here I am telling about the item. Item means what? A particular index. In the particular index, you should not assign any value. Okay, we should not modify the value in the particular index. That's why this is called immutable. Okay, strings are immutable, but lists are mutable. Hope you understood. Tuples also, see, how to obtain the 10 T1 of 0 for all same, because that's why this is called sequence. That's okay, but it won't accept again T1 of 0. I want to assign one more element, for suppose 100, but it won't accept. Tuple object does not support its item assignment. Okay, so sequences are over for us. Okay, so what we studied, very simple and briefly: what are the strings, what are the lists, what are the tuples, and sets. Okay, so sets are nothing but they are unordered items. Okay, so go for sets. See, a set is a collection of items which are unordered, unindexed. Okay, so for suppose these are also collection of different types of items only, but sets won't take the repetition. Okay, so these are unordered items and they are the unordered items. Okay, and here sets won't show the repetition. Okay, for suppose first how to this curly brackets. Okay, sets are enclosed by curly brackets. See, strings are enclosed by double quotes or single quote, lists are enclosed by square brackets, and tuples are enclosed by parentheses. Set is enclosed by curly brackets. Okay, okay, now I want to declare the s1 as one set. S1 equals to, so just I want to set for the some fruits, mango. Okay, mango. Okay, grapes, banana, something. Okay, banana. If you give again mango, now if even though you are declaring this, okay, uh, now I print this S1, only one mango is displayed here. Actually two mangoes are there. The sets, the main important point of sets are they are unordered, and also we can't access the mango like this. S1 of 0 means, okay, set object not subscriptable. They don't follow any index and all. Okay, so this is about the set. Understood? A set is nothing but unordered collection of items, and set won't repeat any items. Repetition of items won't possible. Okay, won't be possible. This is about the sets, and just briefly you can know that. Next, dictionary. A dictionary is nothing but key value pair. Sometimes say maximum this key value, these dictionaries will be used in Amazon and all, no? See, if you TV means 20,000, laptop means 50,000, PC means 25,000. Whenever dictionary one of TV means 20,000 will be displayed. So how to set the dictionary here? So very simple, D1 equals to, okay, and dictionary is nothing but the information will be stored in the form of key value pairs. Okay, so key should be there, value should be there. For suppose TV, the TV is the characters, group of characters, so that should be enclosed in the this parenthesis. Maximum keys will be under the quotes only. Okay, TV, this is 20,000. Okay, laptop Double quotes or single quote, no problem. Laptop, laptop. Okay, how much? This is 30,000, like this. Okay, so 30,000. Next, mobiles. Mobiles. This is about 50. This is 30,000 minus 3,000. I have written. Okay, like that. Just normal. Normally, I just represented the items in the dictionary. Simply D1 means automatically it is displayed. Now D1 of, if you want the TV value, D1 of TV means that is enough. TV, D1 of TV. Okay, so automatically it will be printed. D1 of laptop, again D1 of laptop. Okay, so automatically the value will be printed. So hope you understood. So this is about the data types. Now you understood. Okay, that's why I didn't fully explain in the starting itself. Now I explained everything here. Our mappings are nothing but the data will be stored in the form of, okay, in the form of key value pair. Okay, key means, see, the first values in the dictionary are called keys, and the latter for the key, each every key there should be a value. Okay, hope you understood. Now we'll elaborately we'll discuss about the lists and all. Okay, so here a list. What is a list? A list is a ordered collection of items. Okay, but the collection also different data items. Okay, and which are indexed. Okay, the list is nothing but, a list is ordered collection of items. Okay, otherwise multiple data items which are surrounded by the square brackets. Okay, now see, these are the lists: L1 1 2 3 4 5, L2 AE IOU, L3 1 Kiran, like that. Now see, this list is only numbers, this list is only alphabets, this list is combination. Okay, so this we can write like this: multiple data, different data items. Okay, lists are immutable. That means what? List can be we can assign, okay, any value, we can replace any value within the list. That's why these are called, okay, mutable. Lists are not immutable, mutable. Okay, sorry, lists are mutable. Mutable means they allows change in the item. Once the items are changed, still again we can update it. That's why those are called mutability. Lists are mutable. Understood? And list, already we know that list can be accessed like this. L1 means L1 equal to 10 20 30 40 means L1 of 0 means 100. Just I told L1 of 3 means 300. We know that. Okay, and if we give the, if you want to store any item, okay, any item which is in already, now see, here we got the index out of range. Why? Because the index is 0 1 2 3 4. Within the 4 only you have to you want to try to assign. So L1 of 5 means what? There is no index with 5. Now see, 0 1 2 3 4 only there. Within the boundary, within the index only you want to try to assign. Okay, L1 of 5 means it gives the error. So example, say L1 equal to, I'm giving some 5 values, 10 comma 20 comma 30 comma 40 comma 50 comma 60. Okay, so now L1 of 0 means, so we know that first value will be printed. Okay, now L1 of 1 means 20 will be printed, 2 3 4 5. Okay, up to 5 there is no change. Now L1 of 5, I want to change L1 of 5 with some 100. It is accepting, no problem. So if I print the L1 automatically, okay, it's perfect. But L1 of 6, nothing is there. Okay, there is no index and all. How can you assign any value? That's why this is index out of bound, out of range. Okay, hope you understood. Okay, we know that. Now how to print the this list? There are two ways are there to print the list. Okay, so directly you can give the L1 like this. Using for loop also we can print. Okay, before that, how to print the list means very simple. first is L1 means automatically it will be printed. Not like that. I want to print with the help of for loop. Okay. For that, very simple. For before that, you take there are two ways are there. First way is very simple. This is called traversing. Okay. So traversing means visiting each and every element in the list and displaying is nothing but traversing. Okay. So I can traverse this one using for loop for uh, uh, I in L1. For I in L1 print. Okay. I means automatically all items will be printed. See, so here this is one of the ways. I means what? I represents here not the index. I represent direct item 10, next 20, 30, 40, 50, 100. Okay, until all the elements will be printed, the for loop will print all the elements. Okay, this is called one. This is called traversing, and I can traverse this one with another way also, with the index. With the index means, for that first you have to know the length of the list. Okay, so length of the list means you have to know this function len of L1. Okay, len of L1 means simply it displays. That means what? Six items are there, but index, what is the index? 5 only, n minus 1. N is the length means n minus 1 is the index. 6 is the length means 6 minus 1, 5 is the index. Last index of the list is 5. Okay, now what I want to do here for, okay, I in range, I'm using the range function from for suppose if you don't do anything, just give the 6. Okay, that means 0, 1, 2, 3, 4, 5 will come. In the previous session already we discussed about the range and all. Range generates up to n is there means n minus 1, 6 is there means 5 will be printed. Okay, now print here, very important, you don't print the I here. I means this is the here it refers the index, but here this is in the list only. Okay, in the list this I represents the item, that means 10 here. First I means 10, second I means 20, like that. Okay, but here first time I is 10, second I is 20, third time I is 30, like that, because I in list 1 this is, but here I in range. Okay, now you have to print how L1 of L1 of I, because the 0, 1, 2, 3, 4, 5 will be generated with the I. Now see 20, 10, 20, 30, 40, 50, 100. This is called traversing. Hope you understood. Okay. Okay. Next, nested lists also there. Okay. Nested lists are nothing but list within the list. So L1 equals to, I'm writing one list like this: 10, 20, 30. Okay. Again, one more list: 40, 50. Okay. After then 70. Here, this is nested list. So in the nested list, for suppose I want to print 40, 50 at a time. What is the index? Anyone? Can you tell me? Very simple. L1 of 10 means 0, 1, 2, 3. L1 of 3 means automatically 40, 50 will be printed. 40, 50 will be printed. I want only 40. 40 means L1 of. So 3, you have to give the two indexes. L1 of 3, comma, again 0. Why? Because this is 3031. Two elements are there. Now 30 means 40 will be printed. If you want 50 means what you want to give the index? L1 of 3. Okay. L1 of 3. That means we came up to, we touched this list. In this list, you have to tell the index 0 or 1. I want the 1. So simply give this one like this. So this is called nested lists and all. Okay. Next one, assigning the lists and all. We can assign easily one list in another. For suppose L1 is this one. For suppose L2 equal to, like this it is there. So for suppose I want to L2, I want to take the same list. Simply you can assign L2 is to L2 equal to L1. That means what? Whatever the L1 items are there, automatically that will be assigned to L2. Okay, very simple. L2 means the list That means whatever the items in the L1, those are again copied to L2. So if I print L1, same will be there. If you print L2, same will be there. Okay, this is called assigning the list, one list in another. Okay, so next we'll go for uh, membership operators. It's very important. Membership operators are nothing, are used to whether that item is there in the list or not, to check whatever the to check given item is there in the list or not. Okay, so that is called membership operators. For suppose this is L1. Okay, in this L1, otherwise I will take the new values for L1. L1 equals to 10, 20, 30, 40. Okay, see now. So I want to know whether 10 is a member of L1 or not. So very simple, 10 in L1, 10 in L1. It is there. 10 is a member of L1. Perfectly, it returns the true. Okay. For suppose I want to know 50 is a member of L1. So 50 is not in the list. It gives the false. So that's why these are called membership operators. Membership operators are nothing but whether the given item is there in the list or not. If it is there means it returns the true. If it is not there means it returns the false. Now in is there. Again, for suppose not in also there. For suppose 50 not in L1. This is perfect. Why? Because 50 is not there in the list. But if you give like this, 10 not in L1. Okay, 10 already there. Okay, but 10 not in L1. You are telling 10 is not there in the L1. But this is wrong. This statement is wrong. That's why false. So these are called membership operators. Okay. Next one. Okay, length function. Already we know that. Okay, what is the length function? So length function is used to tell the number of elements in the list. For suppose L1 equals to, for suppose my list is like this, 10, 20, 30, 40 only. For suppose 30, 40. I want to know the length of the list. That means how many elements are there in the list. Very simple, len of L1. Okay, simply it gives the list. Already we already traversed also with the help of for loop. Okay, next we'll go for this list comparison. Which list is big, which list is small. Okay, so for that we are using the operators as usual. We have already we have read already these things in the relational operators: less than, equal to, greater than equals to, not equals to, equals, all these things. So here L1 equals, for suppose I'm taking the two lists. Okay, now already L1 is there. Now L2 equals to some other thing, some others I'm taking. So for suppose 50, 60, 70, 80. Okay, so for suppose this is the L2, this is the L1. Now I'm writing L1 less than L2. So how it will be checked? This many elements are there. Here 4 are there, here 4 are there. How it will be checked? On what basis it is giving? On what basis it decides which list is big? Very simple. It checks the first item in the 50, second item in the, that means the index of 0, first item in the list L2, the index of 0, first item L1. That means index 0 only. So 50, for suppose now L1 is there. I will print the L2 so that now you can see L1, L2. Now I'm giving L1 less than L2. Now what will happen? The 10 will be compared with the 50. So 10 less than 50, perfect. Okay, so no need to compare other things and all. Here itself it is small, so it is true. But suppose if you want to compare L1 greater than L2, L1 greater than L2 means this is wrong. Why? Because the first item of both lists are different. So L2 is the bigger, but this is false. Perfect. For suppose if the elements are same in the list, two lists, then what it will be there? But suppose L1 equals to 10 comma 20 comma 30 is there. Okay, same L2 also. L2 equals to 10 comma 20 comma 30. Okay. Now if you give L1 equals to L2, comparison operator double equal, don't give the single equal. Single equal means what? The items of L2 we are assigning in the L1. Okay, but double equal to means what? We are comparing. Now it gives the true. Both are same, 10 10, 20 20, 30 30 30. But suppose I'm changing L2 as just like this, 10 comma 20 comma 30 comma 40. Okay. Here now L1 equals to L2. Will it give true? No, false. Why? Because up to here L1 is, say, I'm L1 and L2. Now see, 10 10, perfect. We can't say both are equal. We can't say which one is big. Then it will go to the second element of two lists. So 20 20. Here also we can't say which one is big. So it will go to third element, 30 30. We can't say both. Up to here both are equal. But next element 40 is there for this. But here no element is there. So which one is big here? L2 is big. So for suppose if you give here L2 greater than L1, simply it gives the true value. Okay, so if you give L1 less than L2, so because L1 up to 30 30 is okay, but here 40 is biggest. Now it is false. Sorry, L1 less than L2 it is correct. L1 is less than L2. L2 greater than L1 is L1 greater than L2 is false. L1 greater than L2 is false. Okay, hope you understood this uh, comparing the lists and all. Next, we'll go for joining the lists. Very simple. We can join the lists by concatenation operator. L1 equals to, now again, I'm taking new list 10 comma 20 comma 30. L2 equals to 40 comma 50 comma 60. So very simple. L1 plus L2 means automatically the elements are added. First 10 20 30 will be print, after then first list elements 10 20 30, after second list element will be joined. Okay, this is joining operator. Okay, L1 plus L2. Okay, next. So here before that, these are the operations. So what are the operations? Joining is already we have seen. Now replicating the list, slicing the list. So replicating in the sense it repeats the list. Okay, slicing means extracting the subpart of given list. I will tell you in detail. First, joining the list is over. Go for the replicating the list. So here L1. So I want to repeat the L1 two times. So 10 20 30 10 20 30. Very simple. L1. So this asterisk or star 2 means see 10 20 30 10 20 30. This is called replication. Okay, so if you want to repeat the given elements same in the list, but suppose if you give the three times, the elements will be repeated in the list. This is called replication. Next, slicing. Slicing in the sense, in the given list you want to extract any subpart of list in nothing but the slicing. So example, see L1 equals to, again I'm taking new values 10 comma 20 comma 30 comma 40 comma 50. Okay, so here you see here L1 of, okay, now just L1 of 0 means one element only it is showing. Okay, I want 2 3 elements. Okay, so for that what I'm doing here, I want first two elements I want. So see here L1 of 0 is to here this is 0, this is 1. Okay, so but upper boundary should be more than the this one. So if you give the 0 1, what will come? You observe 0 1 means very simple. First element will be retrieved. Second, here 1 means 1 won't be generated, just like a range. Okay, upper boundary should be at least, if you 1 means you have to take the 2. Now you want here 0 1. First element will be there, second element won't be there. So for suppose if you give L1 of 0 is to 2, so the upper boundary second one won't come, but 0 1 will come. Two elements 10 comma 20 will come. So this is called slicing. Okay, so again, this is for suppose L1 of I want up to 40. So what is the range? 0 1 2 3 plus 1. Okay, so don't give the 3 only, because that element won't be taken in the range. So 0 1 2 3 4, if you give the 4, automatically it will be taken. Okay, if you want to 50 means L1 of 0 is to 5. Okay, the fifth one won't be there here. So this is called slicing. Okay, in the slicing you have to know different uh, categories are there. Okay, and this is called positive. Here 0 1 2 3, here see L1 of 0. L1 of 0 means automatically one is say first element will be printed. L1 of 1 means second element will be printed. L1 of 2 means third element, like that all will be printed. We can print this one reverse order also. So L1 of minus 4. Okay, index is 0 1 2 3 4. Okay, L1 of minus 4 means 50 will be printed. Sorry, L1 of 4 means it will come backward direction. Okay, reverse index, that means what? It will go from here starting onwards, it will move back. So if you move back means what? From here onwards it will move backward direction. 1 2 3 4. L1 of minus 4 means 20. Okay, next L1 of for suppose backward direction 30 I want. So minus 1 minus 2 minus 3. So if you give the minus 3, automatically this will be printed 30. Okay, so in this way, this is the one of the notations. This is the negative index. Okay, and here step value also there. Now see L1 of, okay, if you don't mention anything, L1 of this is to. Okay, that means what? Upper boundary, lower boundary are not mentioning. If you print means automatically all will be printed. Okay, now just I want to take some more values, so that 10 comma 20 comma 30 comma 40 comma 50 comma 60. Okay, okay, now I can give the slicing in such a way that, see here, is to, there is no upper bound. That means I didn't mention anything. That means all will come. If we give the step value, what suppose 2 in the sense, every second element from the starting onwards, starting will be printed. Afterwards every second element will be printed. 10 after 30 will be printed, 30 after 50 will be printed. So if you give like this, see 10 30 50, that means what? This is called step value. Step value means what? From starting onwards, how many values you want to take. Okay, we don't sometimes we don't want all the numbers sequentially, same order we don't want. Like at the time you go for the this step value. Okay, for suppose if you give like this, L1 of here 0 is to okay, for suppose range you can give how much, even though the range is here up to 0 1 2 3 4 5, you can give 8 also, nothing wrong. Okay, but if you give this 2, okay, see here 10 30 50 will be there, only same, because we have same range is here full list, here also full list only, even though it is not there, up to 0 1 2 3 4 only, sorry, 0 1 2 3 4 5 only, but it is not the wrong here. If you give the highest also, no problem, you no need to mention the same index more than the our length of, more than index, which is not there in L1 also, that will be valid. Okay, now if you give like this, L1 of 0 is to, okay, now I'm giving 5 only, okay, or 6. Now see, if you give that after then 2, so see, so now 10, 30, 50 will be generated. How it will be generated? First see, this is 0, this is 1, this is 2, this is 3, this is 4, and this is 5. Okay, now here see how it will it is worked. Once you check in the 0 onwards, 0, 1, 2, 3, 4, 5, and 6 is not there at all, but no problem, up to 5 it will be taken. So from the 5, first to 10 automatically printed. From that onwards, second, that means 30. From that onwards, second, 50. Okay, in such a way the values are displayed. Okay, but suppose I'm same, L1 equals to L1 equals to 10 comma 20 comma 30 comma 40 comma 50 comma 60 comma 70 comma 80 is there. Okay, so some more elements: 80, 90, 100, 110, 120. Okay, these are the values. Now see L1 of, now you print L1 of 0 is to, I gave the 8. Okay, 8 is to 2. So what does it mean? So from 8 onwards, first what is the, this is the 10, 30, 50, 70. These many elements are there, but very few elements are printed. How means? First to print the L1. Now check the these indexes. This is 0, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7, this is 8, this is 9, this is 10, this is 11. Okay, now 11 are there. So now what is that our range from 0 to 8? 8 won't be there, okay, because last upper boundary won't be taken, we know that. So from that onwards, first element as it is printed. Okay, that means 10 is printed. After 10, every second element 30. Okay, 30 means the index is 2. Still that is in the range only. Our range is 8. Na? 30 after 50. 50 range is 4. Still our range is in the 8 only. 70. 70 means what is the range? 6. 6 also in this range only. 60 after 80. 80 is the 7th range. So it is exceeds already. Okay, it will generate up to 7 only. 7 means 80. Now after 50, after 50, after 50 second values are 70. 70 means 6 is in our range only. But after 70, what is the next item? After 70, what is the next item? 90. 90 range is 8. 8. 8 means what? It won't be taken 8. Na? Only it will take n minus 1. 8 means 8 minus 1, 7 will be taken. So that's why 90 won't come here. You understood? Okay. Okay. Next, these are all called slices. Still some more types are there. See, if you give the minus in the index, okay, so we have to, what will happen in the minus? Okay, we didn't check the this minus symbol. So per suppose this is the L1. So if we give the, here I have done like this. Okay, if you give the minus index 10, sorry, 11, L1 of 1 is to 1 is to minus 2. So what is the value here? So see here, it gives the slice which contains the mth element by removing the n elements from the end. Now see here, this is the list. Okay, 10, 20, 30, 40, 50, 60. Okay, from here, what are the elements that are taken here? 30, 40. So 30, 40 means it starts from 0, 1, 2. 0, 1, 2. Okay, 0, 1, 2. So minus 2 means what? Which contains the mth element by removing the nth element from the end. Okay, from the end. So actually it starts from 0, 2 only. From the end, okay, starting is, we know that 0, 1 to 30. Ending is what? From here on you have to go back up to 50. Okay, so I will show you here. Same, I'm taking this minus 2. What will happen for minus 2 if it is there in this for upper bound? Okay, so L1, same, I'm taking here 10, 20, 10, 20, 30, 40, 50, 60. Okay, now, okay, he is given L1 of, okay, what is the value? 2. Given the range 2, from the 2 minus 2. Okay, what does it mean? Means, see here, 30, 40 will be printed. First, let me explain this. So now see, for this is 0, this is 1, this is 2, this is 3, this is 4, and this is 5. Now, from 2 means from here 30 onwards, what is the upper boundary? Minus means what? Go 2 steps backward direction from the end. That means 50, 60. Okay, so here 50, 60 means minus 2 won't come, na? 30, 40 will come. Okay, that upper boundary won't come. So here upper boundary is 50, na? Minus 2 means back side 2 steps you have to move. That is 50. 50 won't come, 30, 40. So we will see one more. L1 of L1 of 1 minus is to minus, for suppose minus 2 only. What does it mean? 20, 30, 40. 20, 30, 40 means from the 1, that means 20 is printed. From the end is again minus 1, minus 2, 50 won't come. Okay, because this is upper boundary. 10, 20, 30, 40. Here minus, if it is there in the minus means definitely, okay, you should move back side. Okay, so and here actually, if you represent any index like this, the lower boundary should less than the upper boundary. Okay, this is lower boundary always less than the upper boundary. Okay, here L1 L1 is to minus 2. Here lower boundary is bigger than upper boundary. Minus 2 is always less. This is descending order, it will come, not descending order completely. Here backside it is going. Okay, here some more categories we have to see. Hope you understood. Okay, what is the minus values? Step value also we have seen. Step value is minus 2. Very this is important. Okay, first so L1 of, okay, so it is there like this. What is L1? This is L1. Now L1 of this slicing is very simple only, just small variations are there. Okay, step value already I told. Na? What is the step value? If you don't give anything, if you give the 2 means, if you give the 2 means, what will come? All the list items, every first element after every second element will be taken. 10, second element 30, next 50, 50 after 60 is one more element I want. Okay, every second, this is the first element only, second element I want, every second element. But suppose if you give like this, L1 of is to 1, so you will take each and every element from starting, all list will be printed. If you print like this, L1 is to minus 1. Okay, minus 1 means it reverses the full, okay, it reverses the full list. See here, 60, 50, 40, 30, 10. That means what? Uh, Backside onwards it is printing. For suppose if you give like that, L1 is to minus 2. Okay, minus 2. Now see, L1 is to minus 2. So here, what is the value? 60, 40, 20. 60, 40, 20. So it is starting from here only. So minus 2 means, see here, 60, 40, 20. How the values are printed, we will check again. Here, this is the L1. Okay. The minus 1 means what? From starting onwards, we are starting reverse. Minus 1 means reverse, na? Reverse side, that back side onwards, reversely are taking one element. But here, what does it mean? 60, 40 minus 2 means, uh, see, from same, na? From reverse, from the back side, we have to take first onwards every second element. That means what? 60, after then 40, after then 20. Next element is not there. Okay. So here minus 1 means what? From the back side, each and every element you can take. Okay. From the back side, starting onwards, you have to take every second element you have to take. So this is called minus 2. Okay, don't confuse here. So what are all the things we have discussed? Again, I will tell you, L1 of, okay, if you don't give anything, all will be printed. If you give L1 of, okay, L1 of some 1 is to 8 means within the range. Okay, except 8, all will be printed. If you give any negative value here, 1 is to, or suppose minus 2, what does it mean? Minus 2 in the sense, okay, from back here, back side onwards. So the starting index from 30, minus 2 in the sense you go from here, back side up to, you take up to minus 2. That means what? Minus 2 means what? 50. So 30, 40 will come. Sorry, 20, 30, 40 will come. Starting will be there now. That means 0, 1 means this one, 20, 30, 40. Perfect. 50 won't come because upper boundary. If it is minus 2 means what? You have to understand that backside onwards you have to count up to here. From that onwards you have to take the range. That means what? From 1 to this one. This is the range actually. In this range, upper boundary won't be taken. That's why say this one. Take the L1. Okay. This is L1. Okay. So here 1 minus 2 means what? Minus 1, minus 2. Up to this is the range actually. In this 50 won't come. So remaining 20, 30, 40 will come. Okay. And one more, L1 of 1 is to, okay, 5. Here I'm giving 1 is to, but suppose 10, you can give anything. Okay. Here, if I give the minus 2, what does it mean? So minus 2 means, again, backside onwards. Okay, backside onwards, after first element, every 2 elements you have to take. So why it is giving empty means, so here the index backside means, definitely first should be, this should be the upper. I will give like this, L1 8 is to, okay, 8 is to 2 is to minus 2. What will be printed? 60, 40. Now see, so if it is minus 2 means definitely upper boundary should, first boundary should be upper. That means it's bigger than the second one. That's why 8 to minus 2. Okay, so if it is this one, this combination, no problem. But at the step value is minus means definitely you should follow this notation, 8 comma 2. That means what? They should be upper, they should be lower. Okay, then only, otherwise empty set will come. Okay, so what does it mean here? So from 8 onwards. So 8 is not there here. You give the proper index 0, 1, 2, 3, 4, 5. Or suppose I'm giving 5. L1 of 5 is to 2 is to minus 2. Okay, what will come here? 6 to 40 will come. 6 to 40 means what way it came means check here. This is 0, this is 1, this is 2, this is 3, this is 4, and this is 5. Okay. Now uh, now first 5. 5 means what? 0, 1, 2, 0, 1, 2, 3, 4, 5. From here onwards, okay, your index is this one. After then, you will go to 2. 2 means you will go to here, you are given the 2. So what is the 2 means? Here, this is the 2 actually. Okay. So backwards onwards from this to this. Okay. And this range, from that onwards, we are taking -2. So 60 after 40 will come. After 30 won't come. Maybe in the range is 20 is there means it will come. So here you have to take -2 means, see how the index will be given. This index 5 means this is only. But whenever you give the minus, definitely, okay, you will take this one from here only. So 0, 1, 2, this range. Okay. After then, now this is the range actually. Backside you are going. Okay. So from that onwards, you take the 2 elements. 60 after 40 will come. Hope you understood. Okay, little bit take care about this. If it is minus values are here. Okay, minus values are here mean definitely it should be the upper one. Why? Because we are coming from here to back to here this side. Okay, this side means what? It should be bigger, it should be small. Otherwise, if it is bigger means L1 is to for suppose I'm giving 4 is to 4 is to, for suppose 3 is to 5 I give. All are in the range only. After then, again I'm giving the -2. This is empty will come. Empty means here it is first to 3. 3 means this is okay, and 5 means what? 5 means this one. See 1, 2, 3, 4, 5. Sorry, 5 means this is only 0, 1, 2, 3, 4, 5. This is only, but upper boundary should from here onwards. But already upper boundary it is indicating only here. Okay, and here okay, first boundary is this one, second boundary is this one, 5. So that means what? This should be more. So before example, 5 means here we are. From that onwards, 2 means backside you can traverse. But here backside already we are here 3. Okay, 3 onwards we are going. 5 means forward direction we are moving. That's why it is giving empty. Okay, why it is giving empty means this boundary should be more. Okay, we are moving backward direction means this index should be more. Like that you are moving means the index should be small. But here reverse it is happened. That's why we can't find this range. It is giving empty. Hope you understood. So so this is called slicing. A slicing is nothing but okay, extracting the some part, sub part of a given list. Okay, hope you understood. Thank you. Have a nice day.